one more problem in nodal analysis. Okay, so what is nodal analysis? Yeah, this is a method to find out voltage. Unknown voltage. KCL is applied in nodal analysis. So first step is what? I need to find out number of nodes. Number of nodes. I told you that if all the lines connected in single node, it is only one node. So remember, when you have a resistor in between like this, then it separates two more. Okay? So a center resistor, so this can be taken as node 1 and this can be taken as node 2. And all together everything connected to single point. So only one reference. Okay, because everything connected to single point. So only always reference node will be one only. Right? You can take in the term. Here, if you have a center resistor like this, it is a separating resistor. Before that we have one node, and after that we have one node. So there are two nodes. Right? Now, next what should we do? We should see whether it is a voltage source or current source. We know both are voltage source. So we should convert it into current source. Okay? Right? So we will take the first node. I1 is equal to V1 by R, which is equal to 100 by 20. Right? And I2 is equal to 80 by 10. So converting the voltage into current source, we already know this. Right? So the voltage value is 100, respective resistance value is 20. Okay? So it is 5, right? So 5 ampere. And here it is 8 ampere. Now what is the next step? To redraw the diagram. Okay? So first identify the node. Second step will convert the sources. Okay? Third step is what? Redraw the diagram. So I need to convert voltage source into current source. It is 5 ampere. It should face up because positive is up, right? And this resistor should be replaced here. 20 ohm in series should be replaced here. Again, coming to this side, I have, it should face down because positive is down. Okay? What is this value? 8 ampere. That resistor is 10 nano again should be replaced. So fill in this. So this is 10, 20, this is 10. Remaining what else I have? This part, I converted only this two. And I converted only this two. The middle part should be as such. However, it is like that we should not change the middle part. Okay? So as per the middle part, you have a resistor 10 ohms and 10 ohms and 50 ohms. 10 ohms, 10 ohms, 10 ohms. Okay? Right? Now take this as V1, this is V2. Okay? If you have two nodes, then you have two unknown values, V1 and V2. You can go with normal inspection method. Last problem we had only one node, so directly we use the equation method. Here, when I have more than one, 2 or 3, go with inspection method. Okay? Because in nodal analysis, inspection method will be easier. Right? Up to this clear? What we did? We just identified the nodes and converted voltage source into current source and redraw the diagram in such a way that so center part only you should redraw this part and this part. The remaining part, whatever resistors, whatever it is, as such you should draw. Don't confuse that. Okay? So this is clear, right? Now what should we do? We should use an inspection method. So what is inspection method? Matrix method, right? Matrix method. It is R11, R12, that is for mesh analysis. For nodal analysis, the formula is G11, G12, G21, into V1 V2 because V1 V2 are unknown is equal to I1 I2. Because the formula is V is equal to I into R. This formula we used in inspection method. We had unknown current, that is why we used this. Now voltage is unknown. We should rewrite this formula in such a way that what? I is equal to V by R. I is this, V, 1 by R is G. 1 by R is what? G. So G into V is equal to I. Okay, a nodal analysis, the mesh analysis, we used to V is equal to I into R. Now it is nodal analysis. I have unknown voltage, current is known. Right? So I should rewrite I is equal to V by R. By R is what? 1 by S. So G11 is what? Say, what is G11? R11 is what? Resistance is only in first node. Now G11 is conductance is only in first node. This is node. It is not loop. It is what? Node. So conductance is connected only in first loop. Okay. G12 is what? Conductance is which is connected between 1 and 2. Okay. We know only resistance values. We don't have conductance values. So what should we do? We write 1 by resistance value. G is what? 1 by R. G is 1 by R. So G11 is what? Resistance is connected to first node. Listen. So this is first node. What are the resistances connected? This 10, this 20, this 15. Resistance is connected to first node. Okay, which is what? 1 by 10, 1 by 20, 1 by 15. Clear? Next we will write G2. Resistance is connected only to second node. Again, 1 by 15, 1 by 10, 1 by 10. 1 by 10, 1 by 10, 1 by 15. Again, resistance is between 1 and 2 is first node to second node to none to the resistor is 15 ohms. Okay, so it is clear. It is 1 by 15. So G21 is also what? 1 by 15. Here also the similar values, diagonal values and other values you put minus. Okay, so when I substitute here, how should I write? So we'll substitute here. How should I write? G11 is 1 by 10 plus 1 by 20 plus 1 by 15 minus 1 by 15 minus 1 by 15 1 by 10 plus 1 by 10 plus 1 by 15 into V1 V2. I don't know, that is what I am going to find out. I1 I2. What is I1 I2? I1 is here 5 ampere is flowing towards the node, so plus 5. 8 ampere is flowing away from the node, so it is minus 8. It is flowing inside, it is plus. It is flowing away from the node, it is minus. So 5 minus 8. Just copy this and all. Don't confuse, just copy like this and then go there and then come this balance. Okay, right? You want me to explain again? So G11R resistance is connected to first node. One leg of the resistor should be attached to the first node. Okay, so 1 by 20, 1 by 10, 1 by 15. So G22 is resistance is connected to second node. 1 by 10, 1 by 10. This is also connected here. So 1 by 15. This is obvious. Between 1 and 2, so it is 1 by 15. That is also 1 by 15. Why we are writing 1 by? Because according to this formula, it is G. G is nothing but 1 by R. So we should write only 1 by R. Okay, right? So this formula we have substituted like this. Now solve it and let me know the values of this. This can be solved only with the calculators because we will be getting point values. Here also point numbers, all will be point values. So matrix you need to find their value, their V1, their equal to 5 8. 5 minus 8. You understand why plus 5 minus 8?
Away from the
Towards the node, if it is flowing, it is plus 5. Away from the node, if it is flowing, it is minus 8. If you put this arrow mark wrongly, so here you should see plus sign. Plus is down, so arrow mark is facing down. If you put this wrong, then it will become plus here, then it will probably be wrong here. Okay? So you should know all these indications are very, very important. Understand? Okay? So now let me know the value of V1, del value, del V1, del V2, V1 and V2. Voltage to 50 ohm resistor is 41.99. Current is what? Voltage by resistor. Voltage to 50 ohms is what? 41.99. What is the resistor value? 50 ohms. We need to find out current across 50 ohms resistor. So this is the current across 50 ohms resistor. 2.79 ampere. So when you are writing about current, this is ampere. Okay. So the voltage is 41. You understand how to find out voltage and current? Why voltage is V1 minus V2? It is present between ohms V1 and V2. So the voltage across 50 ohms is what? V1 and V2. We already talked about V1, V2. Just substitute and get it. Current is just that voltage divided by that resistor. Okay. That voltage and that resistor only we should consider. Okay. So this one. Suppose they asked you current to 10 ohms resistor. What is that? Just V1. This is present between 2, but this is directly connected to V1 only. V1 by R. So V1 is 15.1 divided by 10. That's it. Okay, right? Current to this 10 ohms means what? Again V2 by R. Okay. So whatever nodes connected, this both V1. V1 by R, V1 by R. This is V2 by R, V2 by R. This alone V1 minus V2 divided by R. Understand? Understand? Will you find out current at any point? We need to find out current at any point. Why 5 ampere is coming here, but we are getting only less, right? Because current is getting divided in all the nodes. All the ways current is getting divided. Okay? Right? Understand this problem? Nodal analysis is clear? Let's go. So we'll see single phase AC cycle fundamentals. Single phase AC cycle. So far we saw the cycles, those are not DC cycle. Because we had only one voltage source, that voltage source is known to be 10 volt or something like this provided. Right? Which is what? 10 volt. A circuit will constantly receive this 10 volt only. Always. So those type of cycles are known to be DC cycles. Direct current. Directly we are applying 10 volts, it is receiving some current. So direct current. Now we are going to see about AC. AC is alternating current. Okay, the current is always varying. That is why it is known to be alternating current. Here the current will be constant because the voltage supply is constant. Here the current will be what? It is alternatively varying. Okay, suppose say alternatively varying in the sense, and when we take it as a, what is this? Sine wave. So let us say it as time t, right? So at every instant of time, this is time scale, right? And this is a voltage scale or current scale, voltage or side, this will be what? Minus 40. Again it will go up and again it forms a positive one, again it forms a negative. So which is known to be what? AC signal, alternating current signal. Current is always alternating. Voltage alternating, current will be alternating. V is directly proportional to I always. Okay, right? So in single phase AC circuits, we have one phase wire, one neutral wire. Okay, so we have two wires. So one is phase, one is neutral. That is what single phase AC circuit. Okay, you know what is three phase AC circuits? Have you heard about three phase supply? What we receive to our home is a AC supply. I told you already, right? So single phase AC supply means what? Will be writing in this. What it is? 230 volt, 50 hertz supply. Three phase AC supply will be like this. Three phase 440 volt, 50 hertz supply. Right? So why we require a three phase line? What is the necessity of three phase line? Yes? Sine wave is that is representation. For our home, single phase is enough. Why do we require three phase? So it depends upon load. Suppose you have a washing machine, AC, motor, heater, all those things, iron boxes, grinder, mixer, if everything runs on same time at single phase, there will be some voltage. Right? Fluctuations occur. So what it will not handle that load. Okay, single AC is okay. Since some house they have three ACs, three rooms, three ACs, like that, two washing machines. At those cases, the load, electrical load is very high. Some of them have three TVs. Right? At that case, all the electrical equipments cannot run in single phase. So what they will do is they will distribute the load in three phase. They will take three line to O and distribute the phase, which is nothing but loads, which is nothing but heater will be connected to one load, two ACs will be connected in one load, and motor will be connected in one load, like that. So what will happen? Your load will be distributed, which can handle the load easily. So for industrial applications, the single phase is not enough, because industry has a very so we do have many number of fans, many number of lights like heaters, ACs. How many ACs in industry they will have? Okay, so for all those things, single phase is not enough. So they will take three phase and distribute the load. Okay, in three phase, if one phase power is failure also, there will be power in the next phase. Have you seen in your home? If you connected your bedroom in one phase and your car in another phase, there is no power in car, you will be having power in bedroom. Because three phase are coming from three different wires. Okay, which are nothing but R, Y, B, right? Three phase. And one neutral line. Okay, so four lines you will have one neutral line. Three phase. This three phase supply. This is neutral line. Similarly here, one phase supply plus neutral. Okay, this one AC signal belongs to one phase supply. Okay, so this is AC. Why it is called as AC? It is continuously varying with respect to time. Okay, right? So here, if it is three phase, I will be having a signal like this, which means all three are 120 degrees out of phase. See, this is first line, this is second line, and this is third line. All three lines are 120 degrees out of phase, which means it cannot be in same phase. So whenever we are talking about AC, there is something called phase. We will see that in detail. Before that, we will see the generation of AC, how the AC signal is generated. Right? How the AC signal is generated. Suppose Now what is generator? When we have no power in our home or in any office, generator will be turned on, which means what?
Gives energy.
Which gives supply, which gives energy. And voltage, EMF will be induced. How the EMF is getting induced? Electrical energy will get induced. How it is induced? What is working principle? A mechanical energy is converted into electrical energy. A mechanical energy is nothing but when something is moving, rotating, scrolling, those are not known to be what? A mechanical energy. So generator, you remember, they will rotate something and it will start on. Okay? So that is a mechanical energy which converts into what? Electrical energy. So say over here, we are going to generate AC signal. AC is electrical signal. Okay? How we are going to generate a AC signal? That is what, right? So we have two magnets, a permanent magnet, and a coil is placed inside between the magnet. Okay, so we have brushes, commuters, all those things. So now an EMF. These are the permanent magnets. What are known to be permanent magnet? It is always a magnet. There is something called electromagnet, which means what? When I give supply, it works as magnet. When I remove the supply, it is not a magnet. That is known to be electromagnet. So this is a permanent magnet. Okay? Always it is a magnet. I am placing one coil or a conductor inside at the center of two magnets. Already when I place two magnets nearby with each other, magnetic flux lines will be produced between those two lines. In that flux lines, I am inserting a conductor. So what will happen? Nothing will happen. Initially nothing will happen. Now what should I do is I should rotate the conductor. That is what they are rotating. They are rotating, right? They are rotating this conductor. Okay, just for simplicity, we are having one coil. In real time, this will be many number of coils. Okay, they will rotate the conductor. Say for example, we have A, B, C corners of conductor. Conductor will rotate. Imagine this is your flux lines. Okay, this is your flux lines, and you have coil here. Flux lines is parallel. These are the magnets. You have flux lines. We have a coil, right? So coil will be placed at the middle of the flux line. Parallelly, what is parallel? This is flux lines. Here the coil will be placed inserted like this, a parallel. So nothing will happen. Now we rotate the coil. Rotating the coil is initially will be like this. So if I rotate, it will be rotated like this. The coil will be at this position. Coil will move to this position. Rotate. Flux lines will be always like this. Rotate the coil. What will happen? Initially, it will be placed like this. Sometimes after sometimes it will cut like this. If I rotate fully, it will be 90 degree to the flux lines. Again, if I rotate like this, again it will come to the parallel position. Again, if I rotate, it will come down. So it will happen. So what will happen? It will be opposite waving. Continuously between parallel and perpendicular. Parallel and perpendicular, like that. Okay? So you understand? So this coil will be parallel initially with respect to flux lines. If I rotate the coil, it is perpendicular, that cuts the flux lines. And then again I rotate, it becomes parallel. Again I rotate, it becomes down perpendicular. So this is what keeps on happening. Which means when the EMF is induced, when a coil cuts the flux lines. When the coil cuts the flux lines and EMF will be induced. This was Faraday's law of electromagnetic induction. What does the Faraday say? When a current carrying conductor placed between the flux lines, when it cuts the flux lines, an EMF will be induced. When it will cut? When it is perpendicular. Parallel, then won't cut. It will be placed inside. No EMF. Okay? So that is what happened. See, initially at this position, it is parallel. When it is moving, it will be again it comes to this question. Again it is keep on the EMF will get reduced because the cutting area is getting reduced. So it will reduce. Again it becomes parallel, means it becomes 0. Okay. But we notice it downwards. So downwards it will get increasing. Okay. So if suppose at this place this is B, this is D. If this is B, this is D. Coil is completely rotating. Again it is exactly perpendicular. So at negative place it is fine. Okay. Here it keeps on goes back to the original position. So again it is becoming 0. So once I complete cycle, what your coil cuts the flux lines and come back to the original places one cycle. This is how one AC signal is generated. Okay. So we do have 50 Hz AC signal, which means what? Per second, 50 times coil will rotate. I will get 50 AC signals per second. Okay. So this is how. So your EMF AC signal generate paniyacha. Right? We have generated an AC signal. So how we generated AC signal? By using the principle of Faraday's laws of electromagnetic induction. When a current carrying conductor placed under the influence of magnetic field, it cuts the flux lines. When the flux lines cut by the conductor, an EMF will be induced. Okay? So when induced maximum, if it cuts 90 degree, it is maximum. If it is parallel, it is 0. Okay? Right? So like this what? I can generate AC signal. That is how your generator also works. Generates AC then electricity. Electricity is nothing but this AC signal. Right? Yes? So here I have something called number of poles and all. So that we'll see in the next class. Okay, ma'am? So what is number of poles, what is frequency, all those things we'll see in the next class.